Hello, this is Garrick Byrne. Welcome to the second of 3 videos in which I explain my practicum project. To recap from the first video, my idea for this project was to explore how range differs between the 2.4 GHz and 5 GHz Wi-Fi bands as seen in the field. I used my neighborhood as a laboratory. I drove around my neighborhood running Kismet on Kali Linux on the laptop, and for each Wi-Fi access point that the laptop detected, Kismet recorded the access point's name, its MAC address, the GPS coordinates at which it was seen, and the signal strength at that spot. In this video, I'm going to show how I processed the data and describe what conclusions I was able to draw from the data. In order to measure how far the Wi-Fi signals are traveling, I needed to calculate, or at least estimate, the Wi-Fi access points' locations. Using just one access point as an example, each green dot on this map represents a spot at which the access point was seen. The number represents the signal strength at that spot. I took a weighted average of the coordinates and the signal strength to calculate the Wi-Fi access point's location. And yes, I took into consideration that signal strength is logarithmic. Then, for each point at which the access point was seen, I recorded that point's distance from the calculated origin. These distances are shown as green lines on this map. I repeated this series of calculations for each unique access point that I encountered in my neighborhood. This map shows the calculated or hypothesized locations of some of the wireless access points in my neighborhood. Each star is a calculated location. This is not very good. Most access points are outside of buildings, and notice how many of the access points are right beside the road, and that's obviously not right as well. After looking at this map, I wondered if I could get better results with an ostensibly better Wi-Fi adapter. So I ordered from, I think this is some economic development thing to help the tribes in darkest Brazil, but they do a good job. I ordered this external USB Wi-Fi adapter, which claims to be long range. Let's put this long range claim to the test. I drove through my neighborhood again, this time collecting data using the Alpha external Wi-Fi adapter. I positioned as best I could both the Wi-Fi adapter and the GPS receiver outside the car, so there's no interference from the walls of the car or anything. The Alpha adapter did initially appear to be more sensitive. This is the same wireless access point we were looking at before. Compare this map to the map of the same access point detected with the laptop's internal Wi-Fi adapter. The Alpha adapter is seeing the access point more often and from further away. After running these new readings through R, this is what I came up with for the access point locations. And I feel these results are better, but still not particularly good. Note how fewer of the access points are concentrated along the street. Although these results are not great, I think they're good enough for my application, which I'll discuss in the next video. Now that I have all my data processed and mapped, let's reach into the statistics toolbox to visualize and quantify my results. Let's look at these plots for trial number 1. Recall that in trial 1, I used the laptop's internal Wi-Fi card. The data graphed here are the distances between the access points' calculated locations and the spots at which the access points were seen. In other words, if you look at the map in the upper right-hand corner, the lengths of the green lines for all the access points that I found in my study. These are two violin plots with box plots inside. The curved sides of the violin plot show the distribution of the data. See how both distributions show a skew toward lower distances. And this makes sense. You're going to get more sightings closer to the access point. With the 5 gigahertz signals, I get a bizarre multimodal density function. The reason for this multimodal density function is a question for further research. But note that the 5 gigahertz band seems to taper off more quickly, which would support the idea that the 5 gigahertz signals don't travel so far. The medians in the box plots suggest the same. I used the two-sample t-test to determine if there's a significant difference between the means of the two groups. The p-value is practically 0, meaning the difference in means between the two groups is very highly unlikely due to chance. How much is that difference? Perhaps something between 5.5 meters and infinity. That's a rather large range, but that's okay. Things vary so much in the field, I'm not going to worry about it. Let's turn our attention to trial 2. In trial 2, recall that I used this nice long-range adapter. Again, the data suggests that the difference is very unlikely due to chance, and that we can be confident that the difference between the two bands is somewhere between 4 meters and infinity, which is, again, a rather large range. But that's okay. I'm not demanding that the t-test be the solution to all my problems. Now, I'm going to add a consumer reports aspect to my project. I think it would be a good idea to test whether this rather expensive external Wi-Fi adapter is any better than the internal adapter. In this graph, I compare adapter performance on each band. The alpha is on the left and the Intel internal adapter is on the right. We see here that, for both bands, the alpha 1900 unit outperforms the internal adapter. By looking at the p-values, the difference in means is unlikely due to chance. For both adapters, we see some unusual multimodality on the 5 gigahertz band, but that's a subject for further research. I admit that the performance difference doesn't seem like much, but at least now we have a framework for evaluating, for testing, the performance difference between Wi-Fi adapters, a framework we can adapt for different scenarios, and indeed, we can use this framework for testing other internal and external Wi-Fi adapters on the market. So what are the takeaways here? By looking at these graphs and using the t-test, we conclude that the 2.4 gigahertz band is superior for longer range and penetration of solid objects. We also see that, in some scenarios, the external alpha 1900 adapter is superior to the laptop's internal adapter. In the next video, I'm going to show the practical application of my work. So please bear with me for a little while I have a glass of lemonade and collect my thoughts. I'll see you in the next video. Stay with me.